Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is again momentum problem, and to understand that, please refer to the previous problem because it's part 2 to understand it better, and look it in the context of the whole playlist momentum. There are many problems before this, so I don't have to repeat, and I will not repeat myself, and the links are as always in description. But today is a problem about elastic collision. So we have one body M, elastic head-on collision, and this is V initial, and it hits another body of the same mass. Remember, previous time it was different mass, but it hits it heads-on, so all the action is along one axis, and this is absolutely elastic collision, and they want to find us the final speed of those bodies using the law of conservation of momentum. Very powerful law. So not interested what happens in between, how they will interact, how the force will be in time, how it will grow, and nothing interested in these details. All I know that after they collide, this would be this body, and this will have the speed v1. And this would be this body, the second one, and it will have the speed v2. So v1 and v2, and I just draw it very badly. So let's say they collide, and this is v1, and another is somewhere here underneath it, but okay, they travel with those speeds. And the first thing I can say, momentum. Momentum, law of conservation of momentum, and all of this axis. In the beginning, mvi, and this is all momentum that they have. This is initial momentum, right? In the end, this has, first mass has mv1, and second one has mv2. And this is law of conservation of momentum along x. Initial momentum, final momentum consists of two bodies, each moving with its own speed. And so if I try to solve it, I have v1 and v2, two unknowns and one equation, and it would be difficult to do. Of course, mass is irrelevant, so mass will be gone away, and this would become vi equal v1 plus v2, and you will never solve it using only this. And here I make a little stretch. I will talk about the law of conservation of energy. I know it would be the whole chapter dedicated to this, and the whole playlist, and maybe not even one. But it is such a universal law that you are sure you heard it about. So this is only kinetic energy, and the kinetic energy in the beginning is this mass, vi squared over 2, and this is all. And there are no loss of energy, so it's only transformed in one form and another, and in this form it transformed between two bodies. So the second body is the first, after the collision, mv1 squared over 2, this is the kinetic energy of the first body, and then there is kinetic energy of the second body. And that's it. This is initial kinetic energy, and kinetic energy is the whole energy that is there. There is no other form of energy, and there is no loss of energy because this is absolutely elastic collision. And so this is initial energy, it equals to final energy. And final energy consists of energy of this body and this body. Again, mass is a common thing that can be cancelled out, and I have this, I will write here again, V initial equal V1 plus V2, and the second one, 2 is also cancelled out, V initial squared, V1 squared plus V2 squared. And now life is much better because I have V1 unknown and V2 unknown, but I have two equations with two unknowns, and there are extremely many ways how to solve it. But the easiest is let's square the first equation and leave the second one untouched. So if I put Vi squared, and this would be a plus b squared, and go to prerequisite playlist algebra, and one of the first transformations that I speak, and you should know it by heart, that a plus b squared equal a squared plus b squared plus 2ab, right? And in this case, a is v1 and b is v2, so it would be v1 squared plus v2 squared plus 2 v1 v2. And the second equation would be as this. And if I look on this, the only way both two can be satisfied if this thing is 0. Otherwise, both of them cannot be satisfied. But if you don't believe me, subtract. When you subtract this from this, it would become 0. And when you subtract this from this 0, this from this 0, and what would be left? 2v1, v2. Right? Whatever you say, v1, v2 equals 0. And what that means? That means that either v1 is 0 or v2 is 0. Two options. v1 is 0 or v2 is 0. v1 is 0 means that this body stops and this body moves. So v1 is 0 and v2, you put v1 0 and you have that v2 equal v. And this is the solution. That means the second body moves with the same speed. They exchange speeds. First stops, second moves forward with the same speed. Of course, it's possible that v2 is 0, but how this can be? That means this body stops and this body have v1 equals v. That means the first body goes through the second body. It's impossible. It always, this body is always behind. We can always say that in this situation v1 is less than v2, because otherwise it's physically impossible. So that means that in this particular situation they exchange during head-on collision, you exchange speed. And you obviously saw this toy, when there is a number of pendulums, you let it go, this comes here with certain speed, this stops, this starts moving, then this starts moving, hit this, it stops, this starts moving, then this stops, this starts moving, finally this hits this with the same speed, because the speed is always exchanged, and then finally it goes this way, and it goes on the same height because there is no loss of energy, and then the process repeats. So those in the middle, they always stay because they are already touching each other, but those on the side, they always go sideways. Or you saw obviously billiards, various things, that this is a billiard and this is a ball, and you hit this ball straight on, and this ball stops, and this continues to move, and everything in this straight line, and everything heads on, and this is a result of the law of conservation of momentum and the law of conservation of energy. Those two things. And you see, I'm not even interested in the details, only starting and final situation. And I hope you liked it. I hope you will subscribe. And I hope you have a question. And if you don't, that's fine. And if you have a comment, question, or your problem, don't be shy to put it in. And I see you next time. Bye.